going to pick up here at number 7, and we're going to look at a graphing calculator to approximate real solutions. Before I do that, just very important for this year, real solutions are also called zeros, and just remember it's the exact same thing as the X-intercepts, okay? When we solve equations, we call them solutions or zeros. When we're talking about a graph, we call them X-intercepts, all right? So when I look here, I want to go to a graph, but I can't go to a graph until I get everything to one side and the other side equal to 0. So I know you might have had that in the past, but I just want to make sure you understand why we're doing it here. Okay, so that would be equal to 0. Now if we're going to go graph, which I want you to think about, and I'm going to show you this, is we're going to make the 0 y. All right, but what we just talked about is the solutions are basically x-intercepts. Well, what's an x-intercept? That would be the x value when y is 0. So if you think about this equation right here equaling y, well, if I go look at that graph, just remember this equals y. If I go look at that graph, which we'll do, if I try to concentrate on when y is 0, I'm really finding the answers to this problem. Okay, so I'm hoping that's connecting with you, and we'll see. Okay, so I have a calculator here somewhere. That is not it. Give me 1 second. There it is. Okay, so we're going to look at this here. All right, and what I want to do is I'm going to add a graph just because I want you to see this. I'm going to take a little time to explain this problem here because I really want you to understand the entire problem. All right, so you might want to fast forward if you're bored with this. I'm sorry. 3x to the 4th. You got to make sure you hit over on this so you don't stay up on your exponent, minus x to the 3rd. And then we have plus 4x squared minus 5. Okay, and that equals f1 of x. So that's really saying f of x, which is the same as y. And we'll talk more about that this year. Okay, so that's the same. So I'm just going to hit enter here. Okay, so when I graph this, I just want you to see here that I'm going to actually, it's hard to do it on this thing, but I'm going to zoom in a little bit. So I'm going to zoom in here. Okay, I'm going to keep zooming. As you can see, it looks like it's going to cross at 2 spots. Now look at my scale has changed here. This is 2.69 and negative 2.31. So we're looking at, all right, so what are our x-intercepts? Some were definitely smaller than 2.69 and the other one negative 2.31. So here's the deal. I can find them one way. I'm going to show you one way here. I can go to analyze graph, and I can go to the 0, which is exactly what we're doing. Now when I do this, you got to concentrate on one at a time. If I go here and then just go all the way to the other side, your calculator is not going to find both zeros. Okay? Right now it's just finding the left 0. But if I make sure I get here, I've just told the calculator to look between those 2 spots, and I actually get my 0 right here of negative 0.8460. And then I could go do that again on the other side. So again, 0, I'm going to start here this time, and now watch when I go over across that, in this region here, it actually tells me 0.937. Okay, so those are going to be my 2 zeros. Okay, so I could go write those down and be done with this problem. But I kind of want to show you a different way to do it. So what I'm going to do now is I'm going to go back to a graph here. I'm sorry, a calculator page, Scratchpad. And there's a couple ways you can do this. If I hit menu and I go to algebra, whoops, sorry about it. I hit too many things there. So menu, and we're going to go to algebra, and then polytools. And one way to go, there's a few ways to do this right here, but if you go to number 2, real roots of a polynomial, you can just type it all in. So I could literally type in what the polynomial is. So if I take and do this again, which I know I'm not very fast at, so be patient here. Okay, so I have the polynomial in there. Whoops, sorry, I got to do minus 5 at the end. Don't want to make any mistakes. And then watch here, I'm going to hit the comma and then x. So that's the notation of how to put it in. So we want to find the roots for that in terms of x here. So when I hit enter, you can see those look very familiar to what we had on the graph. And hopefully they're still there. If I hit the other button, No, somehow they're gone. Sorry. Let me try one more thing. And there. So here they are. Those were the ones we graphed there. So you can see we found them algebraically here on the calculator, doing all the work for us. Another way to do that, a little bit faster probably, is to go to Menu, and then you go to Algebra. Sorry, Algebra here, if I can get it. And then if you go to Polytools, but you just do the first one, find the roots of the polynomial, but you gotta have kind of know what you're talking about here. It says degree. Well, if we look down here, it actually has a degree of 4, okay? So this is a 4th degree polynomial because the highest power is 4 there. So we want to do that. And then it's asking for all of the coefficients. So if we look at our polynomial, our coefficients in order are 3, then we have -1, then the next one we have is 4. Then the next one we have is, it's actually 0 because there is no x term. You gotta be really careful if you do it this way. And then -5. So if I put that in there, it's actually just gonna build. I'm gonna hit enter here. It's just building the exact same thing we did. It just puts it all in for you. So obviously when you hit enter, you're gonna get the exact same answer. Okay, so I hope that helped you a little bit with finding those. I didn't write down the answers here, but you saw what they were. And it says rounded to 2 decimals. Now, I guess maybe I should talk about the answers a little bit because there's some confusion there. If I write my answers, which are both x values here, it's jumping around on me, sorry. Okay, so these are both x values here. Very touchy. I would write my answers in a few ways. I could literally just say, hey, x is equal to, and rounding to 2 decimals, what would that be, 8.5, and I would also have 0.94 rounded to 2 decimal places. So they could look like that. Another way to write it is without any x equals, and to write them as a solution set. So this is a solution set of answers. Whoops, sorry, just did a very bad thing. There's my bracket. So the braces show you solution set. I was starting to say, and that's why I wrote that parenthesis, is you can't write them as parentheses. Okay, so if you write it as a parenthesis around it, that would really mean an x and a y value of an ordered pair, and that wouldn't work. Okay, you could also write them as ordered pairs, like so, -0.85, comma 0, because that's what they are, x-intercepts. So you could write both of your answers out like this. That is one acceptable way there. Sorry, it's being a little finicky there. Okay, but those are our answers to this problem. All right, so going along here, I'm going to try to pick up the pace so we don't make this video too long for you. This first baseman, Paul Konerko. So if we have a baseball field here, I'm going to quickly sketch this, and it won't be perfect. Okay, but what we got to get here on this one, and hopefully you read through the problem a couple of times. You understand it's 90 feet right here. Now, if you read through it a few times, it says he's directly between first and second. Well, here's first, and here's second. So he's directly on the base path here, and he's 94 feet from home. So this doesn't mean it's to scale, but the distance from here to here is 94. Okay, so hopefully we're getting you to see that you can actually solve this problem with a right triangle. So if we're looking here, which is actually how far from first base is Paul standing, exactly what we're looking for here, that would be really the Pythagorean Theorem, fastest, easiest way to do this one. So x squared plus 90 squared equals 94 squared. Okay, so what do we got here? So we've got x squared plus, and if you're like, oh man, how do I do this? Remember, you can always go to your calculator if you have the squares, but if you don't have a calculator at your disposal, you can hope that your teacher is giving you numbers that you can do that are a little bit smaller. Haha, it's funny because I'm your teacher. Okay, so 8100. And if you don't, I mean, you should hopefully know that one because 9 times 9 is 81, 2 zeros. But I totally get that like this might not be so straightforward to you. So you might use your calculator now, which is fine. Okay, don't forget, we're really looking at the process here. Okay, so 8836. So if we take 8836 and we subtract 8100 from that, we have 736, and then we have to take what? The square root of that answer. Okay, so what we're going to find out here is that we are approximately 27.1, what does it say? I don't know if it's at rounded 2 decimals, but that's fine, 0.13 feet. Okay, so that's how far off of first base he would be. All right, so that is exactly how you would do that problem. All right, so this next one I'm really going to blow up here. Hopefully you can read through it a few times and understand the data here. I guess before I blow it up, we'll talk some dimensions here. This right here is 36. Okay, so 36 feet. And then across, or I'm sorry, the length down here would be 78. So 78 feet by 36. Okay, that's one thing. The service line to the net is 21. So here's the service line to the net. So this distance right here to here is actually 21 feet. Okay, so that's what I have here. And then Dennis is standing on the baseline 2 feet below the center mark. I'm telling you, might have to read this 3 or 4 times till you understand it. But he's on the baseline. You can go either side here, but I'm going to go on this side. Most of you probably did because it's labeled baseline. Here's the center mark, like right here in the center. So 2 feet below would be like right here. So we understand that this gap right here is 2 feet, and this is literally, I guess I can mark it with a D. That's where Dennis is standing there. All right, so I'm going to switch up colors, and I'm going to zoom in a little bit. All right, so we can see this a little bit better here, hopefully. Patience, please. Okay, this is going to be the last problem on this video, all right? And then Miss Tyler will jump up with number 10. Okay, so looking here, remember gap of 2. So the big thing is, like, what's going on? Dennis is serving the ball. So when you serve in tennis, it's going across to here. So he's going to land it in here somewhere. Well, where is it? Well, it says it lands on the service line, okay? So I'm actually going to undo that. I want to make sure that's a nice color that we can see here. There's blue. So it's landing on the service line. So we know X marks the spot of where it hit. All right, so what does this mean? Well, that means the ball went from Dennis. Obviously, there was an arc here, but all it's saying is the spot where Dennis is standing and where the ball landed has a distance of 61 feet. All right, so there's a few ways to do this problem, but I'm going to show you what I think is kind of the best. I really like that you guys would be able to start making right triangles. Okay, so if we went straight across here and straight to the spot, hopefully you're seeing that there is a right triangle right there. Well, what would this distance be? Well, here we are, 78 across here, so obviously half that distance would be half of 78, so we're sitting there at 39. Well, 39 and this 21 that we have already is going to put us right here at 60. So actually, if you look right here, the leg of this triangle would be x. So if we went up here, and I'll keep this in green here, if we did x squared plus 60 squared equals 61 squared, we can solve this problem now. So let's see if you got any better from that last one. X squared plus, well, 6 squared, right, is 36. So that would be 3600. Is that right? Whoops, sorry, went off there a little bit. And then what would 61 squared be? Because this is the hypotenuse of the problem. Do we see that? So the hypotenuse over there is 61. Sorry, got off on a tangent here. So 61 squared is, and you can do that in a calculator if you need to, but that's 3721. And then when we subtract 3600 from both sides, we are getting 121, which is very exciting because when we take the square root of both sides, we get x equals, now, slow down, plus or minus 11. But if you see here, this leg, there's no way that's going to be a negative 11, so we're just going to say positive 11. Okay, so positive 11, what does that mean? Let me grab the black here. Sure, that's good. That means this right here is 11. Well, we need to be careful. Highlight this if we can. This distance right here from Dennis to the center mark here was actually 2, don't forget. So we know this distance right there that I just highlighted in yellow, hopefully you can see, that has it, whoa, sorry, I'm on the wrong tool, let's redo. That has a distance of 2 from here to here. So 11 minus the 2 tells me that this distance right here from x down to there has to be 9. So the answer to this problem, after all that fun, would be 9 feet. All right, now what I'd like to do here is to just show you real quick. I won't take long to do this, but it's a little bit, kind of chaotic here. So I'm going to erase some of this just so you can see how you could do this problem differently if you wanted to. All right, but some people like the ordered pairs. All right, so I don't erase that much. But if you think about ordered pairs, I can do this in red here. This could be right here, since that was down 2. This is a distance right here of half of 36. so that would be 18. So if you slapped right here as the origin, if you wanted to think like that, hopefully you can see that Dennis is actually standing at 0, 16, because to the center mark would be 18, which is half of 36. All right, but it's only up 16 because he's down 2 from that point, so 0, 16. Well then, what would this point be? You got to be very careful here. You are going from the origin, from right here. So how far right would we have to go to get to the service line? Well, that would be that distance of 60. So we're going to go right 60. And you say, well, how far up? Remember, you can't use the 11 because it's like after we already did the problem. So if you were doing it this method, you would be like, all right, well, how far up do I have to go? Well, really, I don't know. Like, I don't know how far up I'm going, would be the idea, okay? So there's a lot going on in this diagram, but really try to make it simple on yourself. You literally have an ordered pair of 0, 16. You've got another ordered pair that makes sense of 60y. And then you have, don't forget this, 61. So when you have the distance formula equal to the square root of, well, look how you would do this. You could do this as 60 minus, I'm going to jump out here a little bit, sorry. You could do 60 minus, well, 60 minus 0, quantity squared, plus, and then do the y's, that would be y minus 16 quantity squared. Well, where is this going to lead? Well, it's going to lead somewhere because, look, if I erase this, what is the distance? Like, we actually know that the distance here is 61. See that? So what we really have right now is we have a problem that we can solve for this variable right there. Okay, so if you're still interested in how to do this, I can show you this. All right, let me keep this in blue, I guess. So what I would do to both sides right now, as I'm moving this up here, is I would square both sides. Okay. Well, we learned that a few minutes ago, 61 squared is 3721. Well, what's going to go on the right side? Well, we're going to have equal to. I just want you to see that the radical is gone because the radical was squared. So that's gone. So all we're going to be left with is 60 squared inside there. That's all that's left. So 60 squared, again, that we know is 3600. And then I would have plus, and this is where it gets a little tricky, you're still going to have y minus 16 squared in there. Okay, so next step here, what would we do with this? Well, let's just hang tight right now. Keep the ugly 3721 equals 3600, but we want to expand that binomial. So how would we do that? Again, binomial expansion, something we're going to do a lot this year. You really have that times itself in you FOIL. So this would be minus 32y and then plus 256. All right, so where would we go from here? So we have 3721 equal to, well, 3600 plus that would be 3856 plus y squared minus 32y. And then what we want to do is we want to get one side equal to 0. So really what we want to do is take the 3856 here and we want to subtract 3721 from both sides. So what are we going to have here? We're going to have 0, which is equal to, all right, well, what would that be equal to? 145 plus y squared minus 32y. Well, we're not used to looking at stuff like that, so let's try this. 0 equals, and I'm going to clean it up a little, y squared minus 32y plus 145. Well, now you would want to try to factor, you'd try to see if you could factor, and it actually can be factorable. Let me just practice the trick we learned before. Let me grab this calculator out and see if we're learning anything here. If we take our calculator and go menu, 3, polytools would be 3 again. And if I do the real roots, if I try this, I can actually type in, you can type in x or y, it doesn't matter, I'll do x. So x squared minus 32x, and then plus 145. See how cool these calculators are for us with respect to x here. So I'm going to hit enter, and it is coming out to squared minus 132 plus. That was not exactly what I thought was going to happen here. Hold on a quick second. Did I make a mistake? So you're going to have to hold on for a quick second here. I found my mistake. Okay, I am really sorry about it. Let me double check. I think I made a mistake right here. All right, so 3856 minus 3721. I screwed up right there. Okay, so watch this. This is actually a good conversation piece. I'm glad it happened. That was really supposed to be 135. So let me fix that. That should be 135. And then this right here should be 135, okay? And then we go back to here. Now here's what's neat. We can learn from this. I don't want to retype all that in. So what I'm going to do is I'm going to hit up, down. I'm going to grab that. I'm going to hit enter down here. And then I'm just going to go in and I'm going to edit it. And I'm going to delete. And I'm going to put in a 3. Whoops. I'll make 2 mistakes here. Delete and make it 135. And then when I hit enter, something really nice happens. We actually get our 2 answers here of 5 and 27. Okay, those are the 2 possible answers for this part of the problem. So you say, well, wait a minute, that's not 9. You got to think about what you were doing. Those are the possible answers for this y value right here. So if I go over 60, I'm definitely not going to be going up 5 because that wouldn't make any sense according to the dimensions of the chord. It's 18 feet to the center service line, so that doesn't make any sense. But it would be 27. So from here to there is 27. So again, how do we get this answer of 9? Don't forget 9 is the answer to this problem because the question said how far is that x from the center service line. All right, so that would be 27 minus this right. Whoops, sorry, this right here of 18. 27 minus 18 would give us that 9. All right, so that was intense. I mean, I went through that. I took a long time to go through both ways of doing this problem, but I truly believe the more you kind of look through these different ways, right triangle distance formula, the better you're going to get for the future on application problems.